Divide the following using either synthetic or long division. 10x squared minus 31x plus 17 divided by the quantity 2x plus 1. Let's start with a little vocabulary. What we're dividing by, in this case, the 2x plus 1, remember that is called your divisor. So whatever you're dividing by is your divisor. And we're always going to take a look at that divisor, and that will help us determine whether we want to use synthetic or long division. So typically, when our divisor is linear, we will choose synthetic division. And this is linear. 2x plus 1 is linear because the exponent of x is a 1. This is raised to the first power. However, when there is a leading coefficient here other than 1, I find it easier to go ahead and use long division. So I'm going to show this example with long division. We're going to set up our long division just like we would with long division for whole numbers. So we are dividing 2x plus 1 into the quantity 10x squared minus 31x plus 17. And this is polynomial long division, and it is going to follow very closely with long division for whole numbers. So I often like to work through a little example here off to the side. An example of long division with whole numbers, which I know for many of you, you may not have done long division in many years by hand. Let's say we wanted to divide 3 into 82. So remember, if we're doing long division, we would really be dividing 3 into 8. How many times does 3 divide into 8? And 3 divides into 8 twice. So we'd have a 2 up here. And then we would multiply 2 times 3. That would give us the 6. And then we would subtract 8 minus 6 to give us a 2. Now, we're not done with this long division problem, but I want to switch over to the polynomial long division so you can see the similarities. When we begin our polynomial long division, we're going to divide the leading terms. So the first term is 2x, and we'll be dividing that into 10x squared. I'm going to show that division off to the side here. So we're really taking 10x squared and dividing that by 2x, and we'll simplify that division problem. So that simplifies to be 5x. So now we're going to put our 5x on top, and I like to go ahead and line up my variables. So I'm going to put 5x right on top of this negative 31x so that my x terms are all lined up nicely. Now looking back at our long division example, we then multiplied 3 times 2 to give us 6. So we're going to do the same multiplication here. We're going to multiply the 5x by the 2x plus 1. So multiplying 5 times 2x will give us 10x squared, and 5x times a positive 1 will be a positive 5x. Now this next step, the subtraction step, is the step that I always worry about for my students because we're subtracting a binomial. So we're subtracting this entire quantity, 10x squared plus 5x. So I sometimes call this my red pen step. I always like to show this in red. We want to make sure we're subtracting both of these terms. So 10x squared minus 10x squared will just be 0. But then we have negative 31x minus a positive 5x. So that will leave us with a negative 36x. So now we're at the same point in our polynomial long division that we are in our division problem on the right-hand side with whole numbers. So going back to 3 divided into 82, our next step would be to bring down the next digit, which would be a 2, and then we would repeat this entire process. We would be dividing 3 into 22. So 3 divides into 22 7 times. Then we would multiply 7 times 3, which is 21. And then we would subtract, and we'd end up with a 1. So let's look at the similarity with polynomial long division. We'll next bring down our next term, which is a positive 17. And then this process is going to repeat. we'll divide the leading term, 2x, into our leading term here, negative 36x. So again, let me show you that division here off to the side. That's negative 36x divided by a 2x, which will simplify to be negative 18. So we'll have negative 18 on top, and now we will be multiplying the negative 18 by the entire divisor. So negative 18 times a positive 2x will be a negative 36x. Negative 18 times positive 1 is negative 18. And then here's my red pen step that I want to make sure to subtract this entire quantity. It has two terms, so we want to subtract the entire quantity. Negative 36x minus a negative 36x will end up being 0. And then I have 17 minus negative 18. So that's 17 minus a negative 18, which is really going to turn into 17 plus 18, which is 35. So I end up with 35. Now back to my example of long division with whole numbers. When we first learned to do long division, you might remember that this was my remainder. So in the beginning, when you first learned long division, you might have been able to, in elementary school, write your answer like 27 remainder 1. But then we learned really what we mean by this is it's 27 and 1/3 as our final answer. And remember, where we're getting that 1/3, we're taking that remainder divided by the divisor. So when you look at the format of your answer, when we say 27 and 1/3, we really mean 27 plus 1/3, although we don't ever write it that way. We always just use the word and. So looking at how we write our answer, the 27 is our quotient. So we're always going to take the quotient, and then we're going to add the remainder. In that example, my remainder was 1. And it's the remainder divided by the divisor. So this is the format of a long division answer, the quotient plus the remainder over the divisor. That's how we got 27 and 1/3. We're going to do the exact same thing here. So my quotient is 5x minus 18 plus my remainder, in this case, which was 35, divided by the divisor, which was 2x plus 1. So the appropriate format for my answer here is 5x minus 18 plus 35 divided by 2x plus 1. Now, if you are interested in checking your answer, let me just show you how we could do a quick check. So let me start with the check on the right-hand side here with our whole numbers. If we were checking our answer of 27 and 1/3, we would multiply 27 times 3, and then we would add back the remainder of 1. So in this case, 27 times 3 is 81, and 81 plus 1 is 82. And that was exactly what we were dividing into. That's called your dividend. We ended up with 82. So checking polynomial long division is very much the same. We would multiply 5x minus 18 times the divisor, which was 2x plus 1, and then we would add the remainder. In this case, the remainder was 35. So if we distribute, 5x times 2x is 10x squared. 5x times 1 is 5x. Negative 18 times 2x is a negative 36x. And negative 18 times 1 is negative 18. Then we'll add that remainder of 35. And combining like terms, we get 10x squared minus 31x plus 17. And if you take a look at this, this is exactly the dividend that we started with, 10x squared minus 31x plus 17. So we have verified that our answer is correct. So 5x minus 18 plus 35 divided by 2x plus 1 is the correct answer to this long division problem.